All right, today we're going to do something pretty cool. We're going to follow the journey of a single click. That one simple action triggers this whole invisible conversation that literally powers our entire digital world. And it all happens because of one fundamental protocol. Let's break it down. I mean, have you ever really thought about it? You type something in, hit enter, and bam, a website appears. It feels instantaneous, almost like magic. But what's really going on is this lightning-fast, perfectly coordinated dance of information between your computer and some server maybe halfway across the planet. That's right. Your computer and the server hosting the website are having a conversation. And just like any good conversation, it follows a very specific set of rules, a shared language that lets them understand each other perfectly. And that language is HTTP, which stands for HyperText Transfer Protocol. Now, I know, it sounds super technical, but stick with me. By the end of this, you'll get exactly what it is and why it's, well, the absolute foundation of the web as we know it.
Okay, so here's our game plan. We're going to trace this whole journey. We'll start with the web's foundation, then we'll break down a web address. After that, we follow the request on its trip across the internet, and finally, we'll check out how the server replies.
First up, let's rewind a bit. Where in the world did this whole thing even come from? So get this. HTTP wasn't dreamed up in some Silicon Valley garage to sell us things. Nope. It was actually developed at CERN, the European Organization for Nuclear Research. And its goal was purely academic. Give scientists a simple, cheap way to share research papers and data. That's it. So a protocol is really just a fancy word for a set of rules. In this case, it's the rules for how a client, that's your web browser, talks to a server. But here's the most fascinating part. It's stateless. That means every time you click, the server has zero memory of who you are or what you just asked for. It's like talking to someone with no short-term memory. This makes the whole system incredibly simple and scalable, but it's also the reason we needed to invent things like cookies, just to help servers remember who we are from one click to the next. Now, for this whole conversation to even start, your browser needs to know where to send the message. And that brings us to the address itself, the URL. And that's where the URL, the Uniform Resource Locator, comes in. It's the unique address for every single thing on the internet, whether it's a web page, a picture, a video, you name it. And every single one follows this exact structure. So if we break it down, it's got four key parts. First, the protocol, like HTTP, tells the browser what language to speak. Then you've got the machine, which is just the server's name. The port is kind of like a specific doorway on that server. HTTP usually just uses port 80. And last, the resource path points to the exact file you're trying to get. Okay, so our browser has the address. Now it's time to actually send the message. Let's follow that request on its little journey across the internet. Before your browser even sends its main request, a little prep work has to happen. First, a DNS query. Think of this as looking up a website's name in the internet's phone book to get its real numerical IP address. Second, there's a TCP handshake, which is basically a polite hello to open up a reliable connection. Only after that connection is solid does your browser finally send the actual HTTP request. And this request isn't just a vague shout into the void. Oh no, it's a very specific, neatly structured message that includes a clear command or method, telling the server exactly what it wants it to do. The two commands you use all the time, probably without even knowing it, are get and post. A get request is super simple. It's your browser saying, hey, please get me this file. But when you fill out a contact form or log into a website, your browser sends a post request, which says, hey, please take this data I'm posting to you. See the difference? One's for fetching, one's for sending. Now, along with that command, the request includes a bunch of headers. Think of these like a cover letter or a bunch of post-it notes providing extra context. They tell the server important stuff like the host website you want, your browser type or user agent, so it can send back a compatible version of the site, and even your preferred language. There's also a cool one called Keep Alive, which asks to keep the connection open, making the page load way faster. Okay, the server's got the request. It knows what we want. Now it's time for it to answer back. This is the final leg of our journey, the HTTP response. So the server's reply looks a lot like the request. It's got its own headers, but it starts with a really, really important piece of info, a status code. And if everything went well, it also contains a body, which is the actual data you asked for. These status codes are all grouped into categories. Anything in the 200s means success, we're good. 300s mean, hey, that thing you wanted moved. But here's the key thing to remember about errors. A 400-level error means the client, that's you, made a mistake. A 500-level error means the server messed up. And of course, that brings us to the most famous status code of all, the 404 not found. And now you know why it's called a client error. It's not that the server is broken, it's that you, the client, asked for something that just isn't there. But when you get that beautiful 200 OK, that's when you hit the jackpot. The response includes a body, and that body is the prize. It's the HTML code, the text, the images. It's everything your browser needs to piece together and show you the web page, finally completing the journey. So there you have it. From scientists sharing research papers to our entire hyper-connected world, it's all built on this incredibly simple, stateless ask and answer conversation that's happening billions of times every single minute. It was designed to be simple and forgetful. And you have to wonder, as our digital lives get infinitely more complex, how long can this elegant 30-year-old protocol hold it all together?